Assalamualaikum and hi. In this video, I will explain on the applications of second order partial derivatives to find critical to determine whether the critical point is maximum, minimum, or saddle point. Okay. Okay. Here is the formula for D. Okay, because you will need this formula to decide on the next thing here. Okay, whether it's 1, 2, 3, or 4. Okay, let's look at it by this example. Okay, let's do example 3. Some steps are done for you. Okay, so example 3 is using the same function as in example 1. Okay, we already solved step 1 in example 1, okay, to find the critical point. And this is our function with two variables, x and y. Okay, so in the first step, you will find partial derivative of x and partial derivative of y. Okay, and also you have found out the critical point is 2 comma 1, 2 comma negative 1. Okay, okay, and then in the next step you will find the second derivative, second partial derivative, second order partial derivative of okay, so you are required to find fxx, fyy, and fxy. Okay. Okay, and how to do that? All right, so we already have partial derivative of x and partial derivative of y. So from here, we will find fxx, fyy, and also fxy. Okay, so let me write here. Okay, fx, so, okay, so fx is 2x minus 4. So fxx means this is the same as this is the same as finding partial derivative of x with respect to f of fx. Okay, so this means 2x minus 4, and then we need to find the partial derivative with respect to x. So this is 2. Okay, so fxx is 2. Now let's find fyy. Okay, fy is 4y plus 4y plus 4. So 4yy means find partial derivative of fy. Okay, and this is 4. Okay, so this is 4. And finally, fxy. Fxy, let me write on top here. Okay, fxy means finding the partial derivative with respect to y of fx. Okay, so this is 2x minus 4. Find the partial derivative with respect to y, and we can see that there is no y here, so this is straight away 0. So this is 0. Okay, thus, as you can see, the second order partial derivative are all constant. So regardless of the 2, negative 1 here, they will remain the same. Okay, because fxx, actually we are trying to insert these two values into the function, into the second order partial derivative. But now since it's a constant, uh, we can never replace x and y in the constant. So this will remain as 2. And then fyy will remain as 4. And fxy will remain as 0. Okay, then apply second derivative test. Okay, this is from the formula given at the top. Okay, you can check this once again. We have the formula for dxy. Okay, check at the top. Okay, so this is given by fxx, which is 2 times fyy of 2, negative 1, which is 4, and then minus fxy squared. Okay, fxy squared, this is 0 squared, and we get 8. Okay, okay, now the value of d is 8, which is greater than 0. Okay, now let's go back to the notes. Okay, what happened when d is 0? Okay, when d is 0, and then we have, okay, we have d equals to 8. Okay, what about fxx? As you can see, we need to check for this, whether fxx is less than 0 or fxx is more than 0. Okay, so fxx is 2, which is greater than 0. fxx is 2. Okay, fxx is 2, and we can see that both are greater than 0. So we have so the conditions that we have are consistent with condition 2. For example 3. Okay, so f has relative minimum. So this will be our conclusion. So that means mana saya punya cursor? 2, negative 1 is a minimum point. Okay, because the conditions are consistent with condition 2. Okay, okay, therefore the critical point 2, negative 1 is a minimum point. Right, so that will be our conclusion. All right, so now if you're okay with the explanation, you can proceed with the exercise questions find the critical points of the function, and then for each critical point, determine by the second derivative test whether it's a maximum, minimum, or a saddle point. Okay, I hope you will do this, and please ask if you have any questions. All right, let me proceed with the next subtopic on Lagrange multiplier. Okay, so for Lagrange multiplier, we have this formula. Okay, suppose we have an objective function subject to the constraint. Okay, so our objective function will be denoted by f of x comma y, and the constraint will be denoted by gx comma y, and we will always equate that to 0. Okay, we construct a new function, capital F, okay, of 3 variables. Now we are dealing with 3 variables because we have x, y, and lambda. Okay, this symbol is called lambda. Okay, and the whole thing here on the right side, or everything here, we call it the Lagrange function. Okay, we have the formula here, fx comma y plus lambda gx comma y. Okay, the number lambda 0 or lambda naught is called a Lagrange multiplier. This is too rigorous. Let's look at the example. Okay, find the critical point of the given function subject to the constraint x plus 2y equals to 24. Okay, so from here we need to modify it to become we need to equate this to 0. So we will have x plus 2y minus 24 is 0. Only then we can say this is our constraint function. All right. And then, okay, this is step 1. Okay, the same as here. Okay, and then form the Lagrange function. Form the Lagrange function. Okay, fxy. Okay, the whole thing here is fxy plus lambda gx comma y. Okay, and then we can expand the equation. Okay, so this is lambda times x plus 2 lambda y minus 24 lambda. Okay, and then in the next step, find, okay, so the whole thing here in the third line is the capital F, okay, or the Lagrange function. Okay, so in the next step, we are required to find partial derivative of with respect to x, y, and lambda based on the third line here. All right, so f of x. Okay, let me demonstrate for for capital F. Okay, for capital F of x. So f of x means 5x squared plus 6y squared minus xy plus lambda x plus 2 lambda y minus 24 lambda, and we are trying to find the partial derivative with respect to x. So we can find partial derivative of this to get 10x. Okay, the whole thing here will become constant, so this is 0, and then we can find partial derivative of this to get negative y. Okay, and then what about this? We can find partial derivative of this to get plus lambda, and this will, the whole thing is a constant, so we will get 0, and also the last term is also constant because we do not have any x term. Okay, as you can see, whenever we do not have x term, we will treat it as a constant. So when we are trying to find the partial derivative with respect to x, this will be straight away 0. So that's why you will get this. Okay, the same as here. Okay, let me do once again for fy. So 5x squared plus 6y squared minus xy plus lambda x plus 2 lambda y minus 24 lambda, and we are trying to find the partial derivative with respect to y. Okay, so the first term will get 0 because we do not have any y term here, and then for the second term, well, maybe I can write it for each term here. Okay, so this will become 12y minus so to differentiate this, we will get x, and then for this we will get 0. For the next term we will get 2 lambda, and then for the last term we will get 0 because we do not have any y term here. So the final answer will be 12y minus x plus 2 lambda. Okay, and this is the same as here, 12y minus x plus 2 lambda. Okay, I hope you will do on your own for the partial derivative of the last line here. Okay, and I hope you will get the same as here. Okay, and then in the next step, you will equate whatever you have found here to 0. Okay, so capital Fx equals 0, capital Fy to 0, and also capital F lambda to 0. Okay, and you will solve the equation by using, you can solve it simultaneously, okay, as what we have learned in the earlier chapters. All right, you can either eliminate or you can substitute. Okay. Um, okay, maybe you can look at here. Okay, lambda. In this case, they are trying to eliminate y first, eliminate lambda first. So that's why they set to lambda equals something. And then for the second term, for the second equation, also lambda equals something. And then since both are lambda, we can equate the right side of the equations to find x equals to something. Okay, 2y over 3. And then we will substitute 2y in equation 3. Okay, and then we are able to find the value of y. Okay, since we already have the value of y, we can simply find the value of x. Okay, by substituting y equals 9 here. Okay, and as you can see, it is not necessary to find the value of lambda. So if you are able to find the value of x and y, basically you are okay. Okay, so what's next? Okay, therefore the critical point subject to the critical point of f, okay, of f, subject to the constraint, subject to the given constraint is 6 comma 9. Okay, so that's how you find critical point subjected to any constraint given. Okay, and now you should be able to do exercise questions. Okay, please do these two questions, and you simply do it by following the steps. Okay, do it one by one. Step one, step two, you simply follow the steps, and you should be able to find the critical point. Okay, and also on this maximizing output. Mm, I think I will explain on this example in another video. All right, thank you so much.